well? Perfect. Okay, so you should be able to say that. Great. So welcome to this session on Lambda under the hood. So let me start with a quick poll. So how many of you are using Lambda today? Okay, so keep your hands up. Keep your hands up. Look around you. Look around the room. So this is like the real pool that we usually have with customers. Everyone is using Lambda. But the cool thing is I'm really passionate about Lambda. I shouldn't say, but it's one of my favorite services, probably this favorite service in AWS, because the novelty and machinery behind the scene of this service is amazing. Spent a lot of time before as a customer to use Lambda, and we use extensively with spiky workloads. I was working in a company that was doing live sports, and therefore you can imagine when you have like, I don't know, Champions League final, exclusive rights, you have like a surge of traffic, and your architecture and our infrastructure has to cope up with that surge. And I thought, you know, I would like to collect all the best practices that I've seen in the trenches with customers and when I was a customer, because I know that in AWS we have a lot of great tips, but are quite scattered across blog posts, videos, etc. So I thought, okay, why not doing, let's say, a talk on trying to gather all this stuff and show the art of possible, but also understanding how to leverage the Lambda architecture for your workloads. So who am I? My name is Luca, 50 cents, because if you translate my surname in English, is mezza, half, and lira is the whole currency in Italian. So it's 50 cents. Yeah, I know. I'm a serverless specialist in AWS. I live in London. I'm an international speaker and a published author. So what we're going to see today, a bunch of things. So first one, we are going to, if you are not familiar with Lambda, I'm trying to give you my interpretation why Lambda is cool. So then we are going to see how the Lambda service is working under the hood. So its architecture, high level, but at least you understand how the things are working behind the scene. We are going to talk about how the Lambda functions are working under the hood. Then we talk about Lambda Containers Image. That is a brand new information that was published from university newspaper, university white paper that was published recently by the principal engineers of the Lambda team. Then we talk about the Lambda function lifecycle, and we end up with some tips and tricks on how to leverage what we have seen today in your code. So let's start with this. So what is a Lambda? And this is a classic question that I receive when a customer for the first time is looking into serverless. So I try to provide like the benefits, because I think it's by far more important than providing like, let's say, the real answer of a serverless service that does that. So you provide code, we take care about running it. And we manage the service, we scale it, and so on and so forth. You pay by the millisecond, so the faster the better. Then you can have different types to package a Lambda. It could be zip, or it could be container image. And you usually go with zip if your package size is up to 250 megabytes. And over that, you have to go with container image. We take care about updating different runtimes, as you can see here in the list, Java, Go, etc. Node, that is my bread and butter. Or you can bring your own. Funny story. There was a customer a few years ago in France, if I remember well, that was modernizing a mainframe, and they love the Lambda paradigm, but they were using COBOL. So they created a custom runtime for running COBOL on Lambda. And there is also a nice blog post on that. So if you're looking for that, it's quite interesting to see that. The other cool thing is scale up in millisecond in response of traffic. But usually what you see is this. So you write some code on one side, and you, let's say, provision your infrastructure in AWS, and magic happens. Everything works. Nice. But one thing that often we overlook is this one. This is like a keynote of Peter DeSantis, one of our VP, last year at reInvent. And I want to catch your attention here. So Lambda has more than 10 trillion requests per month. Now imagine now your workloads when they are spiky or when you have a lot of traffic. Now imagine what kind of engineering architecture and everything you need to put together for handling that load. So that for me is extremely fascinating how people are able to think about creating an architecture like that. So my question back in the days was, as a customer, okay, so it's super cool and does a lot of stuff, but how it works under the hood. So when I joined AWS 3 years ago, I started to dig deeper. And there are a lot of cool things that are happening here. So first of all, we have a distinction between the Lambda service and the Lambda function. Lambda service is what we run, and is all the undifferentiating heavy lifting that we take care of. And the Lambda function is the code that you run, and we partially run into a micro VM. But we will see that later. So let's start with the Lambda invocation model. So there are two ways to usually invocate the Lambda. Either synchronous, request and response, big classic, or asynchronous, through events. That is the two ways. An example of synchronous invocation is, for instance, if you have an interactive workload. So you expose an API with the API gateway. You expect that the Lambda, I don't know, is querying RDS or DynamoDB, whatever, and return back a response straight away, as fast as possible. That is asynchronous. And there are, let's say, multiple services that will trigger synchronously a Lambda. Or there is the asynchronous invocation, where instead maybe you upload a file on S3 and you want to transform your JPEG file into a PNG or GIF, animated GIF, whatever, and you trigger an event. That event goes in an events queue that is owned by us, is managed by us, and that will trigger your code, your Lambda function. So high level, this is what you have with the Lambda service. On the far left of this slide, you have all the services that are triggering a Lambda. Then you have like this pink box with AWS Lambda and different services that are running behind the scene. Now, one thing that I want to highlight, that your code lives there. So as you can imagine, before the event is coming from the entry point into your code, and we provision your micro VM with your code, there are a few things that are happening, and that's why I think is very novel and interesting understanding how the things are working under the hood. But before we go there, I want to highlight another thing that very often is given for granted, and I don't think it shouldn't. So when we are provisioning a Lambda and you upload a new version of your Lambda or a brand new Lambda function, usually we have multiple workers that are running in an availability zone. And those workers can handle multiple micro VM, okay? So multiple customers, and in a worker you can have multiple people, but we guarantee the fact that your code is safe, is not shared anything with other customers, so you are in a good shape. That automatically is, let's say, shared across multiple workers that otherwise you need to figure out how to create the cluster, find the right size of the cluster, and so on and so forth. But moreover, because every region that we have multiple availability zones, so if you think about data centers that are spread geographically distant enough for avoiding, let's say, earthquake or other things, we also do that. So we take care, the moment that you deploy a Lambda, not only to spread across multiple workers, but to spread across multiple availability zones. And if you're a bit familiar with containers or virtual machine, that's not for granted. So you need to figure out the networking part, you need to figure out the right size, you need to figure out quite a lot of things that you have out of the box for Lambda. Obviously, if you have a workload that requires to be even multi-region, it's one step that you have to do that. But again, just selecting multiple regions and structuring your infrastructure as code in a way that is flexible enough to handle multiple regions, and then off you go, we take care about all the rest. So when we think about, let's say, synchronous invocation, we have to think about this scenario here. So if there is an API gateway that is triggering a Lambda, the first thing that happens for every single request, there is a front-end service that picks up the information. And in this case, synchronously is going to ask to the data plane to create in the worker, selecting a worker and then creating a micro VM with your code. The errors, if it happens, are returned immediately to the customer, in this case the client that called the API gateway. And it potentially could throttle if you have like a surge of traffic that there aren't enough capacity for handling that specific surge of traffic. Therefore, you are going to have a 503 error in that case. In case of asynchronous instead, what happens is maybe SNS is sending a request for a Lambda function. the front end picks up the request because it understands that it's from SNS, store the request in internal queue, and then it will be picked up and drain the queue with micro VM with your code, and off you go. The other cool thing is, out of the box, you have the possibility to retry and use it, setting up a dead letter queue, set it up even a Lambda destination. That is the capability in your code to say when the Lambda succeed, call another Lambda, or if it's failed, do another thing. So you have also this capability that is built in with little code that you have to write. So if you think about how to, let's say, write this stuff from scratch, as you can imagine, there is a lot of boilerplate that you need to write and maintain that is usually the painful part on software. Then you have a third option that I categorize as asynchronous, because in reality what we have is a ESM, as we call, or event source mapping, where it's pulling from specific services. So imagine DynamoDB streams, or if you think about Kinesis, and we are pulling this data. And in other cases, if you're not using Lambda, you need to build yourself this capability. With Lambda, you have that out of the box. It's already integrated with all our services. And you can do batching, error handling, and even more. So as you can see, there are a lot of things that are there for free because just use like Lambda. So now let's move on the Lambda function, that is where you have like skin in the game. So when we think about Lambda function, the first thing is that we created Firecracker. Firecracker is a serverless micro VM, or better, a micro VM created for serverless computing that is completely open source. If you want to see that what's inside there, there is a nice link, a website, and you can start to look into that. The cool thing of this is that it took, let's say, an unexpected turn, that it was embraced by other services in AWS. So that tells you already how much we believe into this technology. So when there is an invocation of a Lambda, so we selected a worker and we want to, let's say, invoke your code, first thing that you receive is the input. So the worker host takes care about retrieving the code in wherever place it is, and we will see more in a few slides. And then what we create is this, that basically is your code alongside with the input and a running VM. Obviously, if you selected to go with a zip format, we have all the runtimes available in the worker. So we select the runtime that you selected, maybe Node, and then we run the code and everything is there and is up and running. So it's very simple. Bear in mind, though, that there is a constraint for this model, that it handles one request per time. So till the Lambda is busy doing things, it's very, very important that you remember that the faster your Lambda, the more requests you can handle. So this is one thing that we created back in the days when we launched the service, and it's still there and still a valid point. There is one thing. You can, as I said before, you can decide to go with the zip package type, but you can also decide to go with containers or OCI. Usually when we think about containers, we have these kind of things that are called layers, that in OCI are those kind of layers. So you take like the image and you have like multiple layers that are composing what you want to have inside there. So now these layers capabilities was key for a very interesting approach that we took. So imagine that you deploy a new Lambda with your containers image. So the first thing that we do is storing the container image in ECR, fetching from ECR, and let's say analyze that and store into an L3 cache, as we call, that is an S3 bucket owned by us. So when there is a request, is a cold start. We said that we receive the input, we select the worker host, the micro VM spin up, and then we need to load the container's image. And we retrieve from an L3 cache. This is just for cold start, and if you optimize very well your code, you're not going to find many of them in your code. But then we have an L1 cache that is living at the worker host with your layers. And we have also an L2 cache that is living at the AZ level, and that's the interesting part. Because the L2 cache is shared across worker hosts and shared across customers. And the beauty of this L2 cache is that you have the most common chunks that are available. So for instance, if you are selecting the Python image that is provided by us, or the Node.js image, those layers are already available in the L2 cache, so we don't have to fetch from L3. So the S3 bucket. And this allows you to really reduce the load and let's say, load faster your Lambda function. But there is another caveat. So they are fetching from the L2 cache, but we are not loading all the layers in a container like you would do normally with other orchestration layers. We just load the ones that we know that you're going to use immediately, and then lazy load the rest. And this mechanism was used also nowadays in Fargate. It was announced like literally a few weeks ago. So that is an optimization. Very often people don't think. It's not an easy thing to do with over 1 trillion requests per month and all the amount of Lambda function that you are deploying. And the other thing that a suggestion that I want to give you here is that usually when you describe your, let's say, Docker image or container layers, you start from a bunch of them that some of them are quite, if you want static, they don't change very often, like the OS, the Python version, the AWS SDK, and so on. The business logic is changing very frequently. So when you are describing your containers, try to get the most frequent updates at the bottom of the layer, so we can cache all the layers before because we see that they're always the same, and therefore you can leverage all the caches that I've shown before when you're selecting an OCI package type. Now let's move to the function lifecycle. So there is this fantastic diagram that is available in the documentation that basically explains very easily, in my opinion, how we define let's say, the sandbox lifecycle. So usually you have an initialization phase where we initialize the extensions, runtime, and then suddenly your function code. Then you have the invocation, that is basically your code, that every time that when the initialization is it happened, and that execution environment is initialized, so we just go into the invocation part. And then suddenly when we reclaim the sandbox, we are going through the shutdown. So if you are creating a custom extension, you can also leverage the sigterm signal that is received, and you can allow to, let's say, send data into a server like our partners are doing in the observability side, where they leverage these events for synchronizing with their systems and sending all the OpenTelemetry information or metrics that you need to gather. Now, the interesting part is we have some opportunities here. The initialization phase, it happens just once. So that means things like retrieving secrets or a parameter can be done at that stage. I do once. I have available in my execution environment for the entire life cycle of the execution environment. So when I go on the invocation side, the invocation becomes extremely easy because I already have a bunch of information. I already load the information that were externalized, and I don't have to do that for every single request. So my request can just do business logic needed for fulfilling the job requested by my customers. And then the shutdown, one thing I want to highlight is you don't have capabilities on that side, but unless you have extensions. So it's very important to highlight that. So often I had customers asking, oh, but I would like to have some logic running when I finish the invoke and the execution is about to be, the execution environment is about to be reclaimed. And in that case, the only safe way is using the extensions. So if you want to know more, this link, you have all this explanation that I give you in a nutshell, well explained in the documentation. Now, we have seen quite a few stuff, and we cover quite a lot of ground. So now let's try to look on how we can leverage this information for creating something that is heavily optimized. So the first thing is, one question that I usually have is how should I structure my code? And that's usually a challenge. Because very often I've seen people that normally are coming maybe from the containers world or from the VM world, take the favorite framework and they start to, let's say, write code with that framework. But obviously, more coding means that the size of your Lambda function is bigger, and therefore is impacting your code start as well. One thing that I recommended a couple of years ago, and there is a link on a YouTube video for my reInvent talk there, is leveraging hexagonal architecture that I've seen used quite often in with several communities, like Python, for instance, has a good understanding on that. Node.js so-so. I think Java and .NET better. But the idea is trying to create, let's say, a segregation on the domain logic, so you can iterate better in the domain logic and keep the external world, so the integration with the database or whatever, into adapters. The ports here are acting as a buffer. So the domain logic will never directly communicate with an adapter. Then depends from the language how the ports looks like, but the idea is that one. And then you have like your primary actors, like a service, a front end, a CLI for running tests that are calling your domain logic. And you can do, for instance, testing very well. The hexagonal architecture, when it was created back in 2005, if I remember well, was designed for enabling people to test efficiently, because they have like this monolith and they wanted to handle that properly. And you can apply in a smaller fashion into a Lambda function. You have less code, and it works very nicely. When I started to pitch this idea, many customers started to embrace that with good benefit, especially on testing. But the other thing is, helps you to leverage the evolutionary architecture nature that you should have in your distributed system. Because in secondary actors, we are going to have the adapters are communicating with a database, with another service, with a message queue, wherever. But imagine, for instance, that today you're using RDS, and for any given reason, you find yourself that you have a surge of traffic because you have a service that gained a lot of success, and you want to move with a cache aside pattern using Elasticache. Now, if you have your code regarding the integration that is spread across your entire business logic, is a problem. But because you're using this, the only atomic change that you're going to do is at the adapter level. And you're just adding the additional information related for checking first in Elasticache and then moving into RDS or whatever databases you have. So I have an example with that is available already in AWS samples, and you can find if you watch the video there. I revamped it literally a couple of months ago this summer. So the other thing is caching strategies. There are several ways that you can use caching strategies in Lambda. So the first one is inside the execution environment. So we said before, you can have the initialization phase. You can, let's say, retrieve some data, storing them. They will be available for the rest of the execution environment. Obviously, are not shared between the execution environment, but that execution environment will be able to have them. The other thing is you have a temp folder. If you're, for instance, retrieving some files from an S3 bucket, you don't have every time to go to the S3 bucket. In that execution environment, you have by default 512 megabytes that you can store into the temp folder. You can increase it up to 10 gig. It's quite a lot of stuff. And remember, going to S3, despite is simple and the logic is there, it means an HTTP call. So it means that you need to create a TLS integration, so an handshake between your Lambda function and the S3 bucket, and you need to keep it alive. You need to do quite a lot of stuff. It's not like for free. So if you want to optimize, this is another trick that I have seen used very often. But you can also optimize across Lambda function. That is another thing I think is underestimated. You can use, if you have a VPC attached Lambda function, you can use Elastic File System or EFS, and you can store there. That is, let's say, quite common. So all the Lambda function will have all the data available in EFS because they will plug into EFS. You can use Elasticache, and if you want to use Redis or Memcache, you can use those and apply cache aside pattern, read through cache, write through cache, and a lot of things, and offload the hanging of your Lambda because it's waiting that someone is doing some job. Because the whole thing here is trying to optimize the compute time. So if you are capable to do that, and then you can process later, let's say, all the other records that you need, it's way better. Very often, you know, I've seen in practice, when in my previous company, we built like this distributed system with over 200 microservices, and everyone thinks, oh, everything has to be synchronous. That's not a reality. That's not the business what is asking for. You can work asynchronously, and there are great benefits of doing that. The other thing is, if you didn't try, is power tuning. That if you have a Lambda function, we have this tool that is open source, and you can easily start to understand which is the right size for your Lambda and optimize for cost or for speed. And you can see here where it's the optimization comes from. That's very interesting. We just deploy like step function in your account, and you can run as much as you want. You can have into your CI/CD, no problem at all. Now, an important thing for cold start is this one: reduce the bundle size. So I'm a JavaScript developer, so unfortunately I will provide you mainly hints on that side. But if you're using ESBuild, for instance, integrated with SAM, you can use Webpack if you prefer. Nowadays there is RSPack. I did some tests also there. But stuff like tree shaking, finding the library that will allow you to reduce the bundle size is extremely important if you want to have, let's say, a faster response time of your Lambda function and faster cold start. So minimizing the code if it's needed. So trying to understand how you can really get your bundle size small is an important task that you should check every time that you are adding new features and understanding how the things are working. In node land, top-level await is a thing. You can use that for loading or for calling your SDK information and then storing inside the initialization phase. And that works nicely with provision concurrency. That is a feature that allows us to spin up your Lambda function and keep them warm for a certain period of time. So the initialization phase is done before you have the surge of traffic, and therefore you're going to have the benefit of having always warm responses. So these kind of things can be handled with top-level await and provision concurrency. We shipped, I think it was this year, the SDK free for JavaScript, and it has some cool things. So in the version 2, in order to keep alive the connection, you had to set up a new agent, HTTP agent, and set through the keep alive property. Now in version 3 is already available. Bear in mind that from Node 18 is also available at runtime, inside the runtime. So that means you don't have to bundle every time the SDK. You can leverage, unless you have like specific version that you need, you can leverage that, the one that is available at runtime, and then integrate with that. So when you are bundling your TypeScript or JavaScript function, you just externalize the module on SDK and off you go. Lambda extension is another cool one. Very often we are not looking, but if you have secrets manager or parameter store and you use the Lambda extension, you can set up the TTL. The connection is like a sidecar, so you just communicate through localhost. It's faster. You can have like all the heavy lifting done by the extension, and your code is very neat. Power tools is one thing that I don't know how many of you are using, but it's a fantastic library that for TypeScript is getting better and better. Login, tracing, and metrics that are already optimized for you. You don't have to think how to integrate X-ray, how to do different things. You already have decorators and all the other stuff. And from recently, Hater, that is the chief architect on that, is announced that we have an AWS team doing that. So we are going to have parity between the different languages, and it's going to be quite an important thing. I want to leave you with just one thing. So very often, people think, okay, we are sharing all this information on optimization, but do they work in practice? So I'm working on an example that I try to keep it, let's say, available with all the bureaucracy we have in AWS for today. Unfortunately, I wasn't able, but it will be available soon in AWS samples, so watch this space. And I had like a TypeScript Lambda function was exposed through HTTP API, is VPC attached, querying RDS. And that was at warm start, this is the response time that I had. And doing this optimization, starting to look at the libraries and trying to do all the other things, we moved from 230 to 9 milliseconds. And I also added Elastic Cache because I wanted to have this capability for doing that. But also without Elastic Cache, it's pretty fast. So there is one caveat, though, that you need to remember. There's an article that was released very recently on that. That's why I said it's quite scattered. So if you have like an execution environment that has a concurrency limit of 1,000, so you have your response time is 100 milliseconds, and you have 10 TPS, so you are going to have roughly 10 TPS for that execution environment. So that execution environment can handle 10 TPS. So now the question is, if I have a response time of 50 milliseconds, how long would it take? Any guess? So how many TPS? Should be double, right? But it's not. Because you have to bear in mind that you are working in a shared environment. So the thing is, if a function in a worker starts to have all the resources and draining all the resources, then the others won't be able to handle. So we add also another, let's say, a limit where we can guarantee 10 TPS per execution environment. Usually it's a bit more, but that's one thing that when you are, let's say, looking into your metrics on how you should size your Lambda, et cetera, you need to take into account. So that's all I got. I just want to show you, let's say, all the novelty and the cool things that Lambda allows you to do. And often we give them for free, but they're not definitely free. If you want to drill down even further, there is a fantastic talk that my colleague Julian Wood did reInvent last year. On containers and storage, I recommend to our senior principal engineer from Lambda, Mark Brooker, that describe very in detail how OCI works. And if you didn't read the security white paper from Lambda, I highly encourage because you can find a lot of information. That's all I got. I hope that you enjoyed and enjoy the rest of the conference.
Thank you, Luca. Luca, before you run away, are there any questions for Luca? If you just wait there, I'll run over to you. Abiding by health and safety, as always. Right.
What about if I run off? Hello, thank you for that. It was really insightful. I get a common problem with our clients with using multiple Lambdas and the ability that they don't want to use persistent storage between each Lambda function. And then you mentioned quite a lot about caching methods. Now, the most common solution we use is to store it into an S3 bucket, and then the most common solution we use is to store it into an S3 bucket, and then have an additional Lambda, then query, once that transaction's gone. I was just wanting to pick your brain, really. That would you recommend for smaller files? Normally, we're talking megabytes. Would it be better to cache that? Because the problem we face is you obviously can't orchestrate or guarantee when each Lambda function is going to trigger. So
yeah, I think your challenge is understanding the workload of your customers if they need to share across multiple Lambdas or if you are fine to cache at the execution environment level. Because obviously the execution environment is extremely fast. I did like an exercise in my test where I was retrieving 1 megabyte of file from S3, from EFS, and from the temp folder. Temp folder wins, and easy. So we're talking about a few milliseconds for 1 mega file, so like a couple of them. EFS was, in warm start, was 8 milliseconds, and S3 was 30 in warm start. And therefore, you need to understand where the trade-off lies, because it's all about trade-offs here. It's not about, we are not capable. It's just to understand what we want to achieve and what is the key characteristic we want to implement inside this workload. Is it cost that you care about? Is it the speed of response time, etc.? And then you need to find which is of the different levers that you have in front of you, which one you are preferring. So if cost is not a problem, go with EFS. If cost is a problem and maybe scaling, etc., go with S3, but you have the trade-off of latency, etc. So it's all about that because it's a distributed system, right? So it's like you have to think about having, let's say, multiple microservices communicating together. By nature of networking, it's going to be slower than having everything in a monolith architecture.
Thank you. That answers my question. It's glad that my approach was similar to what you suggest, so that's reassuring. Thank you.
Thanks, Philip. Any other questions for Luca?
Yeah, we have one over there.
Right on the other side. Perfect.
Thank you. Yes, just one typical situation. Yeah, we have one Lambda function which is doing CRUD operations. Yeah, and it's quite normal. I think most of the Lambdas doing it. And on this basis of this presentation, is it better to split this Lambda into 4? So basically we have 4 Lambdas, one doing reading, updating, and deleting, but basically assuming that they all work with the same database, same set of tables?
So thank you for asking this question, because I expected someone ask this question. I wanted to squeeze in the presentation, but I didn't know where to put in the narrative. So again, it depends, but it depends in a good way, in terms that if you think about that, you can have like 4 different Lambda. That could be an approach. But if you look at how your customers usually use a crowd operation, vast majority of the time, people are more sensible on reads than writes. So what you want to optimize is, and then obviously it depends what kind of CRUD API does. So it's like you are heavy on writes, you are heavy on reads. But usually in my experience, the vast majority of them are heavy on reads. So if you split the reads part and you heavily optimize that part, the other one it has way less traffic. So what you have like a great experience. And users, if you think about when you are, I don't know, subscribing to a service or paying at Amazon.com, wherever, you are used to wait. Because when you are paying, you just wait like 5 seconds. No one is complaining because you know that there are at stake your money. So it's similar when you are writing software and you look at your SLA, vast majority of the time you optimize for reads. So if you split in 2, then you open up the idea that you can even leverage CQRS pattern, and you start to have optimization on the reads. You maybe create, let's say, a reads that is heavily, a database table or a structure that is heavily optimized for reads, and you keep differently the writes. So the opportunities just splitting in 2 is amazing, and removes the complexity of handling 4. Now, one thing that usually I suggest to design Lambda or in general distributed system is when a team is owning an API, many times they are thinking, okay, so I need to create this Lambda and this Lambda and that Lambda. But the reality is optimize for the rate of change that you have inside your workload. Because in reality, you are just moving the modularization of your code that you usually have in containers and in VM in terms of controllers and models, etc., into Lambda function. No one is telling you that you need to have mimic one-to-one the representation of a Lambda function with an endpoint. And therefore, if that is true, then you can start to look differently to this thing. I think when I started to explain to customers, don't look at Lambda function like you will treat a container. Look at the bounded context. Look at your microservice. How you want to express modularity in that bounded context. And that opens up a can of worms that is amazing, because you start to have, for instance, the possibility to have like quick acknowledgement on one side, and then you do everything asynchronous. Or you start to have a crowd operation that you split, and you have immediately, like, it is telling you that you can use CQRS, and you optimize that part. So if you start to wire your mindset into where I want to modularize, the world of serverless makes perfect sense, because it removes you a lot of undifferentiated heavy lifting that you didn't have before. So in a nutshell, there isn't right or wrong on having 4 function or 2 or 1. It's absolutely fine, but the traffic pattern tells you what should look like. And I usually say I prefer to split more coarse grain and then eventually more fine grain, because the other way around is painful.
Great question. Thank you.
Thank you.
Cool.
There is one here.
Cool, yeah.
Thanks for the talk, really interesting. And these high-level ideas of thinking about end user when we're thinking about architecture is really, really, really important, really interesting. I come from North Coders. We train people how to be data engineers. And I was really interested in your domain ports and adapter.
Yeah.
How we train, before they come against Lambdas, our students are trained in Node.js backend MVC architecture. How does your domain ports and adapters align with, or how does it relate in concept to MVC, and how might we be able to bridge that gap?
So it's a different model because I think after writing code for quite a few years, I would say the problem with MV star frameworks is the bidirectional nature.
Yeah.
And that was the problem that I didn't understood, because everyone was doing MVP, MVVM. I used even DCI, data context interaction. It's super cool. But the problem is that at some point when their bugs arise, because in software is not building the software problem, it's maintaining the software the real problem. And when you have multiple people putting their hands in the code, you start to have this bidirectional nature. So with port adapters or hexagonal architecture, the nice thing is, you have like the boundary of a Lambda that usually is not a huge logic that you need to wrap. But you split it even further in what is coming in, what's coming out. Because the primary actor and secondary actors, we are going to split that, and you are forced to. And because then you start to think about that, you start to say, okay, so in memory I'm going to create an adapters, and that is my adapters. So if I have to communicate with a database, I have another adapters. And you will see when you are in production, so okay, so I need to implement a cache aside pattern. Perfect, so which adapter I'm talking with? Oh yeah, this one is the database one. The only thing that you change is that. Yeah. Because for the business logic, it's exactly the same thing. Yeah. If you did a good job on removing all the environments, let's say, signals into the business logic. And that is a massive change in the evolutionary nature of distributed system.
Yeah. I don't want to hog the mic, but that's really interesting. And I think one of the biggest challenges for the industry is being able to develop dev teams who have a whole product lifecycle in their mind, so that they're thinking modularly in order to serve the end client. How, in your experience, have you managed to nurture that in people?
The best way I can tell you is my previous company, we moved from 50 people to 3,500 in 18 months, give or take. So that craziness. And we have, the tech department was 550 people. So we had like in 10 months, we built a new dev center in Amsterdam with 100 people, all techies. In order to transfer this mindset, basically was event storming session, a lot of them, and coordination between teams. And event storming basically is a technique that is made with sticky notes, and you just map the business with, or better, the flow for a user with designers, if they are available, the product people, and the techies. Yeah. And the beauty of this approach is that you remove all the technical part. You just say, okay, so I click, I need to sign in on, I sign up on Netflix. Perfect. So I need to enter the email. So next step, I have to enter the password and the marketing preferences. Okay, so that is an event. So email sent. So what's going to happen on email sent? Which service, which system has to be communicated? And then you start to drill down on that. That is not a modeling part that will, let's say, go ahead for weeks or months. It's a low-fi modeling way that helps everyone to focus and share the same language. And I think DDD is often underestimated by engineers because they think that it's too complex. In reality, there are few things that you can pick and immediately apply, like event storming, in your company. We are doing right now here in UK quite few event storming sessions with customers for explaining how it works. And I have like, some of the feedback was, it was like a very big e-commerce, and we're saying, you did in 2 days what we usually do in 6 months. Because you have like 50 people there. Now I know that usually, and that's the problem I had in the past, the C-suite would say, oh, it's a waste of time. But it's not at all. It's where you start to move away and the other cool thing that is happening, I've seen many times, the product people start to understand the complexity that the teams, the technical teams are dealing with, and they bend their features towards something simpler.
Yeah, and begin to understand the blockers that they have, and it's shared language. That's brilliant. I've got one more question. No, I'm so sorry. If there's no one, I'm so sorry. In that the product shutdown, the Lambda shutdown phase.
Yeah.
A question of security. How do you ensure that there's nothing persistent that leaves any intellectual property or any security vulnerabilities?
When we claim the image, from what I know, I don't know the technicality, how they do that, but from what I know, they clean up everything and it's always fresh. But I cannot tell you what is let's say, what are the operations that they do, because, also for us, I had to spend like a lot of time with the principal engineers in Lambda, and it's difficult to find time for them because they're quite busy. And basically, because I was curious, I started to say, okay, this is a whiteboard, so explain it. And that's how I capture a lot of the stuff. Yeah.
We've got time for one really quick question. Cool. Yeah.
Over there.
And it has to be really quick.
I will be available for the rest of the conference, so pick my brain as much as you want.
Great talk.
Thanks.
So I've recently been working on a solution which is deployed now, and we've load tested it up to 10,000 transactions per second via API gateway. Yeah. One of the issues we found as part of that load testing is API gateway invoking the Lambda function was taking between 140 to 180 milliseconds.
Hang on, what is taking 140, 180?
It seems like the request going to API gateway, then API gateway invoking the Lambda function.
So the invocation part is taking that long?
Yeah. So do you know
VPC attached?
Say again, sorry.
VPC attached?
Yeah,
or
VPC attached as well.
Okay. So probably we need to look into the networking part.
Yeah.
Because I believe that is unusual, that time. Because, for instance, the metrics that they shared are the metrics from a VPC attached Lambda.
All right.
Yeah. I think we need to look into what's happening when the request is coming into the VPC. Yeah. And maybe you have firewalls, maybe you have other things that are running over there, knuckles or security groups or other things, because it seems a bit high.
Yeah.
But I would, first thing first, I would look into that. And the example is very easy to understand if it's true. So you take the Lambda function, you mock all the dependency inside the VPC, and you run outside the VPC.
Right.
That is probably the easiest way that you can say if the problem is the API gateway or is the networking setup.
Yeah, I'll have a look at giving that a try as well.
Yeah.
Thanks a lot.
50 Cent, you're here all day, right? So
yeah, of course.
Cool.
In the house.
Great.